So welcome back to the lab for another short demo on electronics. Now last week in my video I introduced this pure tone generating box which I put together very quickly involving a quad operational amplifier in the biquad filter topology. And it's just given me a pure tone out the audio band, and we discussed that circuit a little bit. So this week I decided I was going to build another similar box with an identical biquad filter in there. The only difference is that that last of the four op amps is built into a sweep circuit. It's generating a sweep, which moves the filter around to act like a swept-tuned analog spectrum analyzer. I mean, that it might be a strong term for it, but it's really an audio sweeper. It's the exact same set of caps, the audio band, and it's got a linear frequency display and linear vertical. So it's just an audio sweeper. So I've got the same 9-volt battery, one knob, an X signal, and a Y signal. This is set up as a vector plotter, and we're actually looking at the sweep generated from this unit right now. So if I go ahead and hook up the Y input here, we'll see that this is the output from a biquad filter, and it's actually way off scale. You can see it there. So normally what I do is just bring that down to make it sort of look like a spectrum analyzer. And well, once again, this is linear, and I don't know if you can see it on the camera display. I'm sure it's interacting. It's the exact right frequency, or the exact wrong frequency rather. The dot is actually moving really fast on the right side of the screen, and it's moving fairly slowly. It's like slowing down, getting stuck, landing into sand or something, and slowing down. So this is actually a curved sweep, which is traveling really fast over here and slows down. And you need that to sweep the audio band. Oh, it looks like we're getting some lightning again. There's a thunderstorm here, so you'll see some discontinuities and stuff. I probably shouldn't really be doing this right now, but there you go again. But anyways, it's not within a few kilometers of here. I should be good there, but anyways. Okay, so right now, the way I have this set up, I don't exactly know. 6 kilohertz center frequency. Up on this side, I got 12 kilohertz, and whoops, off the screen. Over here, it's 2 kilohertz. So it's this is a pretty small span, right? But that's controllable on this sweep. And so, well, first let's prove to you that it's linear. I'm going to go ahead and switch to a square wave so I can see the harmonics there. And it's linear, you can tell, because they get wider. Um, that to a point, it actually does hit a point where it starts to log, but it's only right in that corner, so it's not. Okay, we'll switch over to a triangle to show you that it's triangle less harmonics. You might have to boost it up to look at it. Oh wow! Now the lightning's really coming in. Okay, so the difference between the loudest tone I can look at and the tiniest tone I can look at is about 70 dB, but not at the same time because there's a lot of bleed. It depends on how far away you are. So I'm gonna give it a 60 dB dynamic range for most of the stuff that I would tend to do with it. I think that's basically. Let's go to a sawtooth. So now it has the even harmonics in it too. And there you can tell that it's a linear display. So we'll go back to a sine wave here. And what else was I going to do? Oh yeah, so how the sweep works is it doesn't change the top frequency, which is about 20K. So you can move it back and forth using the scope controls, but it controls how far down the oscillator gets before it relaxes and jerks back up to the top frequency. So if I make that sweep longer, what happens is the frequencies start to come up, but you can see the sweep is way slower. It's going ka-choo, ka-choo, ka-choo. And you need to do that to actually get down to the real audio band. So I'm at 2K now. If I go down, I don't know if this is going to look right on the screen, but now I'm at 1K. And really, the practical limit here of going, I can go any amount down, but and this is a sweep circuit like you're more used to seeing probably. I'm just gonna scale this a little bit, but anyways, you get the idea. In order to get down to like the tens of hertz, it actually takes this long. Okay, so let's go back up to, and this actually looks okay to my eyes. I could totally use this display. I bet it looks like shit on the camera, so my apologies for that. Whoops, that went way slow. I'll speed it back up. Probably looks okay there. Let's go all the way up. Just bring it back to about a 6K center. I like this. This is nice for just having it sit on the bench. All right, so I want to show you the sweep circuit I made. If you want to understand the actual oscillator, the resonator rather, the filter that this is based on, you should check out my previous video on the topic because I get into the nitty gritty there. And but I'll just show you the sweeping circuit. And so once again, this biquad is controlled by LEDs shining on voltage controlled resistors. And this last op amp is driving another LED, a yellow 0603, which shines on a LDR hooked up to the positive, and so that creates feedback through an RC, and so the phase shift of this is actually it's actually meets the oscillator criteria, if you think about it carefully, because there's no negative, so it takes an infinite time, or like it's kind of hard to explain, but it's an infinite decay. It never really reaches zero, and so um, it this and this the RC are truly integrators, and so the phase shift actually works out. Uh, yeah, I don't know. Oh yeah, well, if you think about this too carefully, it doesn't make sense, and maybe the clever people that watch this channel can put in the comments how this is a why I say this is a sketchy sweep generator, and maybe you shouldn't expect this to work with all op amps. Question mark. Okay, well, that's it for now. Just a fun little circuit. I can't imagine seriously using this for audio work, with the cheaply available FFTs and stuff. But I learned a lot about swept tuned analyzers. So yeah, thanks for watching.